Guys, welcome back to my channel. Today I'll be talking about centripetal acceleration and centripetal force. I'm going to talk to you about the first part. It is pretty straightforward. Now, let's do centripetal acceleration. So centripetal acceleration always point towards the center of the circular path. This is a circular path and this is a bob. Let's say a string is connected to a bob and the bob is moving at this direction. The centripetal acceleration is pointing toward the center path, and the velocity is tangential to the path. The looks something like that. There's a formula and another formula. So you've noticed something that these are the same. You can combine those. So usually we can v squared over r. So my bad. V over r is equal to the sum of the radial force over the mass. I'll talk to you about this formula later. Okay, so the horizontal circular motion, the vertical forces and they are balanced. And the only horizontal force is the tension. So the expression for radius is the mass times the velocity squared divided by the tension. Now, vertical circular motion, we have this. So, something like this. On top of the circle, there's the tension force and the gravitational force. I do not need to talk to you about this later because we're going to use it later. And the other angle is using trigonometry and this. Legit the same thing. Okay, let's move on. Let's consider our first question. Find the tension of the string where the pendulum bob is at the top. How do we solve this one? How do we start with this problem? Let me just change my color. Okay, so there's a few steps to solve the problem. The first thing we do is to draw a diagram. After the diagram, you calculate. Okay, great. First, let me just draw a diagram of this. Switch the color. Looks much better. The color. So now, the bob. At the top, you have a gravitational force, mg, and the tension force, which is very important. Okay. Great. So now we can use the formula that we have. Remember the formula that I talked to you about? I hope so. Remember that I said it can be packed like this. Again, I hope you remember. Now, what is FC? What is the sum of the effective centripetal force? Well, it is equal to the mg, which is in the positive direction because it's pulling towards the center, and the tension force. So in this case, we have the formula that the speed over r is equal to the 1. The next other question is equals to mg plus ft right over m. It's pretty confusing. And let's plug it into the equation. So after rearranging, we get the tension force is equals to the mass. My bad. Kind of annoying, right? Tension force equals to mass times v squared over r minus mg, the gravitational force. So after we plug it in, we find that the answer is 5.55 newtons. And the answer is 4.55 newtons. I hope you learned something from this question. Before I move on to a more difficult question. Next question. Okay, it looks very dazzling. It is a 3D shape. It is a conical pendulum. I hope during the masterclass they'll talk about this during that Centripetal masterclass. And if they talk about it, you know how to solve it. Since then, we want to find tension T. Just make it bigger for you. From this angle is 30 degrees, and then about 3 kilograms. Find tension T and speed of the pendulum bob. Okay, let's start. Remember the 2 ways I told you how to solve the problem? This is so the first method we have to do is to draw the diagram. The diagram is absolutely necessary. Right. Looks like this is permanently stuck. No idea why. Gonna erase it. Okay, so what is the second way? The second way is the way that we calculate. So how do we calculate? Think about this question for a while. Pause the video and try yourself first. Okay. I hope you try this problem. It might be quite difficult, and it's okay. Let's do this together. The first thing we find is to find tension T. Again, we draw the first diagram of this. And I am a very good person. I helped you draw the gravitational center tension force in this figure. So I made this figure by the code using overlay. Okay, so again using the formula, again using the good old formula. That's y equals to the sum of the forces, the radial forces divided by the mass. So look, is the pendulum falling down? It's not even going down in a direction. So this acceleration is literally the zero. And if it's zero, what do we know? There is another force counteracting the gravitational force. You might ask, hey, where is this force? I'm going to show you right now. This is tension force. We can resolve this vector by breaking down into two different force vectors. Let's call this Tx, call this Ty. Sorry, Tx, my bad. Wait a second, let's call this, let me draw it much better. Not a laser pointer, but yeah. So let's call this, it goes up, Ty, and the horizontal Tx. So we can easily tell that what? That Ty is equals to the gravitational force because it has nothing good. So just to mention that if this is our angle, theta equals to 30 degrees, then ty will be equal to t cos 30, and tx will be t sine 30. Okay, so ty equals to mg, and tx, right? So 0, using the same formula, 0 equals to negative mg, because I'm just pointing down, and let pointing up be a positive side, plus t cosine 30 over m. And in this case, what is t? We can derive t, which is mg over t cos 30, right? So, not mg cos 30, my bad. So, plugging in the values, we get t equals to 34n. So, did you get the first one right? Alright. So, did you get the first one right? I hope you did, right? It's pretty easy, it's trivial, and you should know it. Okay, for Newton. So let's do the second one now with a completely different color. I love yellow. Let's do this yellow. Okay, great. So it's much harder, and we have to use that again using the same formula. Right. We do it again using the same formula. Also, I like to say that this question is from Khan Academy. They gave this question, and I really loved it, so I decided to talk to you about this in the video. So now we have the velocity squared over the radius, which is equals to t sine 30 over m, because tx is t sine 30, and the centripetal acceleration is due to tx. So still pretty easy questions, trivial. And v squared over r is t sine 30, right? Over m. We got it? Right. And so it's pretty obvious too. Now we continue. The 2 over r is, what's r? What's r? Just a question. What is r? Which is very annoying sometimes. So what is r? And I want to say that r is equal to l. So what's l? Let's name this l. Sorry, this is l. Let's name this maybe like 2 meters. Let's just call it 2, which is 2 sine 30. Right, 2, then sine 30, which is this part. That is 2 sine 30 over the equal to t sine 30 over math, which is 3 kilograms. So writing the equation, and that t is equals to, so not t, v. There's a big problem here. Then is equals to, v is equals to square root of rearranging everything. L sine 30. So again, I use L for 2 because I don't really want This is the capital L. This is a small L over M. So this method is quite similar to the Khan Academy one. The answer is around 2.4 meters per second. Thank you, Khan Academy, for providing me with this question. I would like to spread it out to more people. That's why I made this question, make this video on the question. Again, thank you everyone for listening to this video on centripetal acceleration for SJPO Prep Series. Goodbye.